Awesome. So today we are talking about object-oriented programming in Python. So Python is an object-oriented programming language. So everything is an object technically. So Booleans, strings, hashes, arrays, they're all types of objects. Can someone tell me what object-oriented programming is? Does anyone know? Any guess? Just throw it out there. Yeah, Kenneth.
I'll take a stab at it, but from what little I was looking into, it looks like you just make these classes, and these classes can do different things. And then whether it's in a separate file or even in the same program, you just take that and plug it in there. So I guess you're building blocks of stuff, and then you can use them interchangeably, and still kind of fuzzy on it, but that's what I got out of it.
Yeah, we definitely do use classes to deal with objects and stuff like that. So object-oriented programming is a computer programming model that organizes software design around data or objects. So we care about the data that we're having, that we have and we're working with. So we kind of design our program around building classes that hold this data into an object. Yes. What was I going to say? All right, I'm distracted by the noise. Okay, so objects are data structures, and these objects have attributes and methods. So think of objects as a noun. So it's a thing. So like dog. Dog is a noun, can be a type of object. So most nouns have attributes or adjectives. And you can think of this as if a dog has a color and a breed and a name. These are all attributes of that object. And then you can also have methods that can do things with that data. It can do things with those attributes. So you can have the dog speak or fetch or do something. And objects are organized by classes. So classes are going to be used to combine how data is represented. And it also it combines the data that is being represented to with the methods that manipulate that data. And we'll obviously see examples of this. But yeah, it was mentioned earlier today in the stand-up, but we have some features or principles of, I like the word principles more. Principles of OOP. And this is the only thing that I'll be typing out, but so what is encapsulation? If anyone has looked into this, maybe over the weekend or.
It's, if you can hear me, my Wi-Fi is really bad for some reason. It's when you purposely like hide your code in various ways, like using functions or getters and setters to kind of keep your code hidden. So instead of directly accessing certain variables, you would use a function to get the information you need. It kind of puts further layers of separation between the data in your program and the people using it.
Yeah, basically that is exactly what it is. I would change just we're not hiding the code per se, we're hiding the data, so the data access. So encapsulation is pretty much data access can be restricted based on needs. So you can have a bunch of attributes attached to your object, but not necessarily all of them will be accessible by your user unless they're accessing it through a function. So we'll talk about that later, but a main thing for this is it allows us to protect our data from being updated in a way that we don't want it to. So let's say we have I'll give examples later, but any questions on this? Pretty much just giving certain permissions, certain attributes. So, okay, what about abstraction? What does it mean to abstract something, even if it's not within this context?
To not get it too much into the details, just keep it nice and vague for basic understanding.
Yeah, definitely. So abstraction in OOP is where our logic is pretty much hidden for simplicity. And inheritance. So these we'll kind of see today. Inheritance and polymorphism, we'll see more of that on Wednesday. But what do you guys think inheritance is?
That's when you get two classes. Say for example, a class could be people, which could be like a name and age, and then you would have like class that'd be like student, which will go more into detail. I can take can inherit the attributes of like that people class into it. It could be like student ID, name, and age.
Yeah, definitely. That is what it is. So this is pretty much sharing of familiar features and attributes. Polymorphism, which was mentioned this morning. Do you guys remember?
Objects kind of taking different forms and stuff.
Yes. Did you read that from the curriculum?
I had it on my notes, yeah.
Yeah. It's okay because I'm also doing the same. So polymorphism is you will change what an object looks like based on what you need it for. So we won't see that specifically today, but we'll see that on Wednesday. Okay. So yes, these are the principles of OOP. So let's get into the code and actually see how a class can be created or how an object can be created. To start off with, to define a class, you use the keyword class and then give it a name. Typically for classes, you give a name with a capital letter in the beginning, just to denote that it's an object. So I'm going to create a class dog and then colon. And for now, I'm not going to put anything in here. So I'm just going to put pass so it doesn't give me errors. And let's call this, let's say Vivo equals, oops, dog. This is how we instantiate a class. So now, if we run this, we're not really gonna get anything because we're not printing anything, but a class can pretty much be viewed as a concept or a blueprint of some idea. And so when we create an instance of this class, it will be kind of like a copy of it. So this is going to give us the blueprint of a dog, but when we're creating an instance, we will have a copy of that, a specific version of that.
And just to add to that metaphor, like I sometimes think about it like the class definition is like the blueprint for what we're building. And then the programming language goes ahead and like that's the machine that goes ahead and builds it. Like if the blueprint is for like a doghouse, like when we instantiate a new instance of that class, it goes ahead and builds, well, I guess, a dog, really, some magical machine that's going to go and then create a new dog for us.
So
That's a great
you're
metaphor.
creating a brand new object with all its attributes and features, basically, right?
Exactly.
Yeah, awesome. Yeah, totally.
Okay. So this is pretty boring. We don't really have much in here. So let's add, we'll add some attributes. So what happens when we do this? We say dog and then we call it like we're calling a function or something like that. So here, it actually goes to a method that's built in that is underscore underscore init underscore underscore. So this is a built-in function that will get called every single time you instantiate a class. And the first argument is always self. We will talk about it in a bit. So if we call this, this gets called. The importance of us being able to define this or overwrite what is already there is we can actually take in parameters into our instantiation. So let's say we want to give our dog a name. So we can say, this dog's name is Bibo. It's kind of a silly name. And so to give this dog an attribute, we use self dot name equals name. And so this, when we call this, it should give us a dog with a name attribute that is called people, and we would be able to access it. So if we do this, we can just print, oops, people dot name. This is how we can access the attributes. It should print out, where am I? In the wrong directory. There we go. So it printed out our name. Okay, questions right now? No, okay, I'll talk some more and we'll probably have questions later.
I do have one question.
Mhm.
If you're initializing anything for a class, is it better to have one giant initialize block with all of the potential variables?
Yes. So it depends on what you're doing. Sometimes you might, if there's like a lot of logic and you're not just defining variables, you might want to take out some of that logic into a different function. That way you can just call the function. But typically, yes, you will do your initializing inside of this init function.
I understand what, or I think I understand what self means, but are there two arguments in the def underscore init? How many, is it one or two arguments there?
It's one to many. So in the beginning, if you don't have any arguments in there, it will just be self. If it is, you can go, I think there's, I don't know what the cap is, but you can put in as many arguments as you want.
And right now there are two arguments in our init function, and self always has to be passed because I suppose if we weren't setting any properties for fields on our class in the init function, maybe we wouldn't have to pass self. I would have to double check, but we'll see that all the time with classes, with any methods that we're defining on a class where we have to actually pass the reference to the class itself, self as the first argument.
this seems notably different than what I've seen in the past where they seem to open this with curly brackets. Maybe I got it wrong, but
JavaScript, that's JavaScript.
okay.
Sorry, I didn't mean to jump in. And yeah, it does get confusing. The context switching is a little confusing.
So self is always gonna be our first argument when we initialize the function.
Yes, and
Okay.
you can name it whatever you want, but this is an industry standard that wherever you have this init function, you'll have self in here.
Okay.
Also, so it's not only going to be in this method, any other method that we create will have self. So let me explain what self is. So self is pretty much, it gives you access to the instance that it's calling from. So self refers to this specific dog. So if I had created another dog, I can't type that. So if I created this other dog, the self that is here will differ based on if it's this one or this one. So I don't know if I made that confusing, but does anyone have any questions on that?
So self refers to the variable in the instance.
It refers to the dog object that was created.
Okay.
And say you had multiple classes on like the same thing, how is the self gonna identify if it's within that instance, like if it's underneath it?
Same, what do you mean, same classes?
So like say you had class dog and class bird, right?
Okay.
Like you have two different classes
Mhm.
and you're using self on both, how is it gonna differentiate between?
So this is an internal method or an internal variable, so it will make sense within the context of a dog or within the context of a bird. So here we're using, so actually let me do this.
And I was gonna say too, we could just print out FIFO's name.
Yeah. So when I'm printing out FIFO.name, what it's actually doing behind the scenes is kind of like a self.name, and it's printing that out. So this is just an alias, so I can call this whatever I want. So the self or the name is contained within this object that we have created. So if I print it out, it's just going to print out the name. It'll make a little more sense as we add methods and we use it a little more.
I have a question about the instantiation. Why do we use it if we can just print dog Bibo, for instance?
So what do you mean? To just print? So
if we do print dog Bibo, it will still dog.
Okay, so this entire thing?
Yes.
Let's see what we get. We will get a dog object. That's why. So the name is inside the dog object. So a new object was created that has an attribute called name. We can add, let's say, breed and color. So breed equals breed. Is it double E or EA?
Double E.
Okay. Self dot color. Color.
And just to add to what you've been saying, Zainab, like the whole idea behind a class is that we all the time, like we will have data and we will have logic, right? And we've seen, and can people hear me? Okay, thank you. We've seen like in JavaScript and in Python, like we have different data structures to store data as it gets a bit more complex. Like in Python, we have a list. I can't remember if we've looked at a dictionary in Python or not, but there's a dictionary type. JavaScript has its own objects type, which by the way can be very confusing because objects in JavaScript work differently from objects in Python. So everything we're talking about today with regards to kind of objects in Python is not going to translate exactly to JavaScript. And you know, you can even put like a list inside a list, or with JavaScript an array inside of an array. And then you can put all kinds of variables in there and build up pretty complex data structures, right? And as we started to see, like when we write our programs and we write functions and we write logic, we have to know kind of the shape of that data. Like, am I passing an array into this function? Does this array have another array inside it? Does it have strings? Does it have booleans and so on? So in reality, when we're writing programs, the shape of our data and the logic that we write are interrelated for so much stuff. And kind of this is a good example. Like we could create a list in Python and have the first element in the list be the name of the dog, and the second one be the breed, and the third one be the color, and have that be a convention. And we could write a function that would take that list as input. And if we wanted to get the dog's name, it would print out the zero with the very first thing in the list. And that's kind of how programming worked through like the 50s and the early 60s. And then this idea of object-oriented programming and a class came together that basically said, hey, like we want to be able to connect data and logic together. Like when I'm writing a program where I have to like deal with a dog database or a dog inventory or something like that, I don't want to have to make these assumptions all the time. Like, is there a way that we can combine the logic and the data and write our program so that it's harder to screw it up, essentially? And that's kind of part of the inspiration behind the idea of object-oriented programming in a class. And when we create a new instance of the dog class, when we create a dog object, like on line 10 where we created Bebo, or on line 14 where we created FIFO. So that, like a class is kind of like a special data structure in Python. Python knows to go ahead and call this init method. There's also a method called new that gets called every time you create a new instance of a class. And that kind of happens under the surface and we don't really have to worry about what that does. But that does this work to return a Python object. And we would say that the type of that object is, well, we might not say type, but we would say it's an instance of the dog class. And the object itself is a complex data structure, as we can see, and it's got these different properties. And we're going to see how we can also add methods to it as well. Because there were some really good questions about like, what is this Bebo variable that we've just created? And what is this FIFO variable? And what happens when I'm creating multiple dogs? And what if I have multiple classes? And to kind of wrap all this up, because a class is a more complex feature of a language and a more complex data structure than just like a list, for example, or an array, it's really common when you define a class, when we create one like we do on lines 1 through 7, to want to be able to have different parts of that class definition talk to each other. Like we might write a method soon to like print out a message where the dog says, hello, my name is Fido, or something like that. And that's where the idea of this self variable comes from. And you can think about it as like each object is a little self-contained world, but then to find all the things in that world, you use this self variable that Python creates for us to access the different parts of the instance of our class. Because there were some really good questions about well, how does self work and how does self work between classes? And again, folks mentioned in the chat, like scoping and namespacing, and that's exactly right. Just like how if you define a variable inside a function, it only lives inside that function. This special self variable only lives inside each instance of a class. So I'll just pause and stop there and just check in with the class to see if that context was helpful and if people have any questions.
Oh, question. How do you go about like making the attributes like private?
You might be muted, Sana.
Thank you. We will be talking about that tomorrow. But yeah, that's that. Okay, is anyone still having a hard time like wrapping their head around this, or no? Okay, I just wanted to give this example of every dog will have these attributes, but whenever we instantiate it, we're pretty much taking a copy of this. And instead of each of these, instead of it being just a blueprint, this will actually contain the names that we brought in. I think I mixed a few of the attributes, but it's okay. Read color, okay, no. But yeah, that's basically what it is. It's taking that structure and then putting in the data that we want it. And then when we're doing self, it will be each instance will have access to its information. Okay. So let's add.
Zainab, can you run those print statements? Can you run this application and see what they print off then?
So this first one is going to print out that this is a dog object and where it is in memory. And then this one is just printing out the name of that dog. So if I wanted, I can just print.
So why is the first statement not printing out the entirety of those colors and type, like gray, husky, woof, woof?
We will get to that in a sec. So
Okay, sorry, yep.
So when you're printing out an object, it doesn't have a built-in way to print out its attributes, but we will learn how to do that in a bit with a specialized method that is included.
And as you folks are noticing, special method names in Python have the two underscores in front and at the end of it. Like for special methods and variables that the language uses in some fashion.
Yeah. And one thing I do want to note is you will never explicitly call this init function. Once you call the class, it will automatically do it itself. So you never want to call this init function from anywhere. Okay. So these are called instance attributes. So they're just attributes to dog that we will be able to access. It's placeholders for data. Now we will show some methods, some instance methods. So for here, let's say if we do speak, a method called speak, and inside this will also contain self. And for speak, we just want to print out the sound. So let's say, let me format it. And it's just going to be self.sound. So this is why we want to use self. It allows us to access the attributes within the class methods. So now if I do speak, so now that's a method down here, you see it. with the parentheses, it will say woof woof. And we can also do any other, like, let's say, define fetch. And here we want to just have self, and maybe we want to actually send in an item or an item name. And then print out. Let's say that name is fetching this item here. So item, there we go. So if we say, actually, we don't even need a print here because we're actually printing inside thing itself. Forgot about that. So we can do FIFO dot fetch, and we can send in ball.
David, I have a quick question.
Mhm.
What are the arrows in the F function?
Oh, this is just for formatting here. It's just to make it look like
Oh,
it's an output. It's just a string. It
okay,
doesn't-
okay.
Yeah. Adam, you were gonna say something?
Someone in the chat had the same question.
Oh, okay. Awesome. Any other questions? Okay. Does anyone not understand any of this stuff here? Like why we're doing what we're doing? Yeah, Kenneth.
Not necessarily, I don't understand, but it just seems kind of redundant to just go ahead and create all these new, I'm assuming those were, like, we wanted it to say speak, why would we not just go FIFO dot sound and print that instead of making a whole new,
You could. So these are just
Function.
for, these are just for demonstration purposes. So you will use
Okay.
these methods for more complex things. But for now, I'm just
okay, all right, that makes sense.
demonstrating that you can do that, yeah.
Yeah, like maybe we want FIFO to say, hello, my name is FIFO, and I'm a golden retriever.
Yeah.
Jacob.
If you didn't pass an argument into fetch, would it throw an error or would it do like just put in like a null or an undefined for the argument, or how would it react to that?
Let's test it out.
That's a good question.
Here we go. It's giving us the missing required argument.
Okay, cool.
I think Python is different than JavaScript in that regard. Where Python will complain if you define a method or function that takes two arguments, but you only pass one. Where JavaScript won't complain about that specifically, I think.
Yeah, I think so too.
Kevin.
Yeah.
Oh,
Is there a way to set like default values as well? Let's say, I mean, every dog barks, so you could do woof woof for like as a default, and then for particular dogs, if they're different, you can, okay, I was just checking if it's. Okay.
Yeah, definitely. So you can have here, like you can have a default here if you still want to take in a sound. But if not, you can have nothing there, but you can have nothing there, but here you can define it as woof.
And if you construct a new expression of that, of a dog, and you don't enter that, that will be injected, or?
It will be it will be used if you have a default. So if I have woof here,
yeah.
and I didn't send in anything here, when we say speak, it should just say woof. Yeah, there we go. Did that make sense? Or did I answer your question?
Good questions, folks.
Anyone else? Okay.
Are people starting to feel more comfortable about the self class variable? Sorry to interrupt, Zaina.
No, that's okay. Yeah, so if you have a method that only has self, you will not be sending in anything because this is just automatically inserted in. Cool. Okay. Okay, so there's a thing called a dunder method. Let me just oops. Dunder. And it what's the word? It stands for double underscore. So double and then underscore. So it just refers to any method that is built in to Python that has double underscores before and after. There are many. We have a link over here. Sec. To show you. So this is in the curriculum. It's a very good resource. But I'll just show you a list. So you can pretty much, it allows you to override operations. So if you want to add, there's a method for that. You can override it by inserting this into your class. Same with all the regular operators. There's also, you can override the print method, which is what is important to us now, because if you guys remember, if we print out this, oops, when we print out just the dog, we're getting an object, or like just the fact that it's an object. But let's say we want it to actually print out more information. We want to print out all of the information that we have here. So to do that, we have to do an override of that method. So underscore underscore str underscore underscore. So what this means is this just converts your object to a string. So whatever it returns, it will be printed out. So here we have access to self, and we want to return a string. We can format the string. Let's say, how do we want to format this? We can just say name, colon, and then self dot name. That's for now, we'll keep it simple. So so this print statement should now print out something other than this. Let's test it out. And there we go.
And if I'm using the term right, I think we just demonstrated polymorphism by overriding the default behavior of a class's underscore string function method.
Yes. Yeah, I agree. So yeah, this is an important one. You will probably be using this more often. I can demonstrate one of the other ones. So if I say fine, add. So when you do add, there's going to be a self, and then there's going to be an other. And I'll explain which one's which after this. But let's say when we add, we just want to, oops. I can just say the names. So self.name, and then comma other dot name. And let's see what this does. if we do print people plus, I don't know why you would be, you would need to add dogs, but this also works. So if you print out what happens after you're adding these two, this is what we're getting. So just the name and the other name. So the first one is going to be yourself, and then the second argument is going to be other.
Is there a way to print the entirety of a record without coding it as a method or that additional function down there?
I think if you cast it as something, it might, but it would have to fit into like fit into certain criteria. Let me try.
I'm perplexed. You can't say print FIFO and you don't get the entirety of the record as compared to just getting its location in memory.
And when you say record, do you mean
Sorry,
the instance? Yeah.
Object, or I guess I'm thinking of the dog named FIFO. So,
Yeah.
yep.
So yeah, that's a really good question. Sometimes we will have classes where we'll talk about private properties later, but there may not be any information inside the class that we want to directly print out return, where the class may be doing something like sending HTTP requests and not have a lot of meaningful stuff to print out to begin with, or there's no way maybe for Python to know which of these properties are the ones that are relevant. So I'm not certain, but I think that's why there's that default behavior. Sorry about the echo.
Oh, was there? I didn't notice one. I'm sorry. I should have muted. Okay, since we actually just mentioned private variables or attributes, so to make it private, it's just 2 underscores, and this will make it unavailable to be accessed out here. So I cannot just say Vibo dot what was it that I hid? Breed. So actually, I'm not sure if I put the 2 underscores, it'll, yeah. So it has no attribute breed. And if I put just regular breed, it will also say it has no attribute. So in a lot of cases, you would want to make something private to not allow, like I said, the user to change it inappropriately, or maybe you don't want them to be able to see it or access it, and they can only access it through a specific method. So if I hid sound over here, oops, that was the wrong. So if I hid sound, I would only be able to access sound through the speak method. And that's where it would come in handy. Yeah, kind of.
Just so I'm understanding the verbiage correctly here. So self.color, self.sound, those are all instances of the class dog.
These are all
Or those are
attributes.
Attributes.
These are
Okay.
attributes, yeah. So it's kind of like saying here, there's something that's called name, and it's equal to something. We can say an empty string now. Oops. I actually think you have to do this. So, oops. No. No, you can't access it. Yeah, in other programming languages, you would usually define your variables at the top, and then you would modify them inside your init function, or you would in a lot of languages it's called a constructor. So you would do that, but here you can just define them inside here. So all of these are going to be our dog attributes. Any other questions?
Rico had a question in the chat, but could you maybe repeat it, Rico? I wasn't sure I understood.
So
Yeah, sorry if you guys have you can hear some background noise, but I was just wondering, to make a property, or is it called like a field private, do you use the double underscore? Is that the
Yeah.
same thing?
yeah, that's what this one is doing here. So breed has now become private because we added 2 underscores in front of it.
Does that? Does that actually? Is that a convention or
No, yeah,
it enforces? I actually didn't.
yeah, because I just tried to print out the breed and it doesn't exist.
Strikes
Oh,
me that,
cool.
that great usage for that might be if dogs had social security number, the
Yeah.
DSN. And you didn't just want anybody to be able to call that value.
Yeah, because that could be a value that you're only using internally here. And you only want to use it to like verify something or something like that. And yeah, you don't need it anywhere out of the class, so you shouldn't have it outside.
So
Yeah.
the double underscore, you only apply those to the attributes?
Yes.
Okay.
Let me actually see if I put it here. I think also if you put it in front of a method name, you can only access that method name from inside the class itself.
Okay.
I've never tested this out, but I'm guessing this is a thing. So if I said vivo dot fetch. This is gonna give an error. Yeah, it has no attribute fetch. So, yeah, that makes it also a private method. And similar to what we were saying about the attributes, if you want to hide them, you might want to have internal functions that you don't really need the person on the other side of the class to be able to access, because you only need it internally. When you're maybe initializing something, you want to have some logic to put dogs in categories or something like that based off of breed, or I don't know. I'm sorry.
No. And also we'll make stuff private when we define classes to indicate to other programmers how this class should be used. So there's a lot of that. And I actually didn't know about the double underscore for class properties. And you'll hear us say field, property, attribute. They all get kind of mixed up, but probably property attribute is a little more correct. The double underscore is kind of interesting what Python does. And it's not relevant for now, but I'll share it in the resources channel. And essentially, Python treats anything with that double underscore a little differently. It's a little magical. It's not a true private variable the way a language like Java might do it. But for all intents and purposes, for us, it does the same thing. I'll share the link in the resources channel. Thanks, Anna.
Of course, thank you. Yeah, Nick, I think you had your hand up first.
Yeah, I think I'm just a little bit confused on what's happening behind the scenes here. Like, so are all the Dunder methods automatically called when you initialize the class, or is that just the initialize method?
Yes, it's just the initialize method.
Okay, so then
yeah.
I was also curious as to how it knows, I guess, or what it's doing to modify the print statement. And then the arguments you passed in the add function, you just pass them with a plus instead of separating them. And I wasn't sure how it was knowing that that's what you were referencing.
Okay, so this, let's start from the first one. So,
Okay.
when you instantiate a class, so when you have the class name followed by parentheses, it will call an init function. And this init function will, if it doesn't have, if in your class you don't have an init function, it will just create a dog object and then return it to you. It will just create an object that doesn't have any specificities. So it won't have attributes or anything like that because we didn't define an init function that would add any attributes. So by us creating this, it will override the default one and it will create the attributes as we want them to. And you see here, once we send in arguments, we should also be expecting those arguments back here in the self-defined init function. And that's how we can make sure that we create all of our attributes that we want. For string, I believe when you try to print something, it checks for its string version. I'm not, yeah, okay, good.
The string method, yeah.
Yeah, so in Python, it knows that this string method is what you can use to override that. So if you want to print an object, you will always see, and not always, but most times you will see an override with this dunder method. That way you can, that way you can print out something legible from that object. Were you going to say something, Adam?
So then in the future, if you want to make that property printable, when you want to print this object's or this, this object's information, you would add one or many there.
Yes, you can have this return anything you want. But since you're trying to print out this specific instance's information, it would be helpful if you actually have the attributes in there. So it depends how you're using it.
So let's say we were collecting the dog's first name and last name, and we wanted to give that dog an email address. Can you construct their email address by concatenation in that string line?
Yes, but so I guess the question is, you can just concatenate strings, obviously, but is that what you want to print when we try to print the dog object? Is the only thing you want to print the email? If so, then you can just do that. You can make an email out of it and have it print there. So it depends on your use case. If I'm trying to print out this dog instance and I only care about name, breed, and color, I don't care about the sound, then that is what I will probably put in my print, in my string override.
So let me extend that question again. Then can you have a definition for email address? And instead of concatenating inside of the string, can you simply include the email address as a return in the return line?
Yeah, you can include anything as long as you're returning a string, you should be good.
Yeah, we could. Should we write a method that returns an email address for the dog, like name@canines.org?
Yes. So yeah, can you show us how you would then add how can you define an email address for this dog and include his name at?
What did we say at?
Canine.com or
Yeah.
Is that how you spell can, or is it with the C?
just K9. Yeah.
C or K?
C.
C, okay. And then So email and then email. So this is if I didn't add the email as an attribute, I'm just creating it here. Hold on.
Why don't you create a new definition for email? Instead
A
of
method.
Oh, a method.
a
Yeah.
method for an email address? Instead of subordinating it under the string.
Yeah, I can define create email. So this will just take in probably self. And then return. I'll return this. Which apparently this one. Yeah, I realized my mistake earlier. Okay, self-name dot that. And then I can delete this. So you don't want it just to return, you want to add an attribute? Is that what you're saying?
I'm just asking, and then down below on the string line, you need, yeah. So where
So
does that?
here, here
is
I
that
can just
underscore
call,
email?
yeah, I can just call the function. But I would have to use self because it won't recognize it otherwise. So self.create email, and it should return the email that we created. Let me just, which one is it? Fetch. There we go. So this is what happened when I just printed this. Does that answer your question? Yes, no? Okay.
I saw a bunch of hands go up.
Yeah, let's see. Nick, did we answer your question? Or I was in the
Yeah,
middle of
I
it?
think we got to, so I wasn't understanding that it just essentially class, when you call that in general, it's always going to call in a init function, and then you're just overriding it there. And for the other ones, I think that I just need to go look at what those are doing behind the scenes so I understand them a little bit better. But your explanation explained kind of what they were doing. I just think personally, I want to go and look a little bit
Okay.
deeper.
Yeah, that resource is very good.
And I was going to mention too, for the dunder string, the double underscore string, and the dunder add methods. So maybe not every single, so everything in Python is an object. Without going like too deep into it, there is some kind of like base class for like the like initial like platonic ideal form of an object that's like super simple. And then we'll see how like all our other classes kind of inherit and build from that. But point being that what the Python language does is it gives not everything, but lots of things a dunder string method. And you can think of that as sort of like almost like a default method that exists on like all sorts of classes and objects. And I don't know if that directly addresses your question, Nick. I saw some other questions about that in the chat. And that's why, like, if we print the number 7, we see that character 7 because the instance of like the integer class, the integer object for that number 7 has a dunder string method that says, hey, this is the character that you should return when we need a string representation of this integer. Similarly, I don't know them all, but it looks like Python has a dunder add method that many objects may have. Again, integers probably have their own dunder add method, which is why if we do 3 + 7 in Python, Python knows what to do. And so we can kind of override that too. So there's all these kind of like built-in methods that like objects in Python have that we can override. And that's what we're doing with the string method and the add method, dunder string and dunder add. And what's very, and as you folks are starting to see, the way all this stuff works with computers in general and with programming languages and with programming is it's all about a ton of assumptions. Like when we use the print statement, like Python assumes that whatever we're printing has a dunder string method. And if it doesn't, it has some sort of default behavior. So it's like there's all these assumptions and conventions about how things work. And that's kind of what ties everything together. I don't know if that was a little too far left field, but I saw some really good questions on that stuff and just wanted to share. Oh, Zainab, I think you're muted. And we have to mute and unmute because we're in the same room, which is super annoying.
Actually, when Adam's talking right now, was there like a double thing or no? Okay, so I can stay unmuted. Perfect. Okay, but yeah, so one that would be pretty powerful is the equal. So if you have two objects and you want to make sure that they're equal, you can overwrite the equal operator. And that way, when we do this, we can return true or false based on certain criteria inside of the dog object. So that's also something that is interesting. Yes, Lewis.
Okay, so I still don't get how like Python will understand. So for example, if you were to comment out the definition of add, would it still print out the two names concatenating together when you use the plus sign?
It will not. Here, unsupported operand type for dog and dog. So it doesn't understand trying to add two objects of type dog together because it doesn't exist. So when we're actually adding a string with a string or a string with an integer or something like that, all of those methods are predefined, and Python will know what to do with those two objects together. And it will, if it's strings, it will concatenate. If it's integers, it will add, stuff like that.
And just to add on that, so that plus symbol, like what happens when we run this program is Python sees that and says, oh, that represents the add method, the add. So when Python sees the plus symbol, it says, okay, let me look at the thing to its left, in this case, Bibo, and call Bibo's dunder add method and pass in whatever's on the right of the plus symbol. And like if we had like 3 plus 7 just typed out or something, then Python does the same thing. It would look at, and actually say, can you just type out 3 plus 7 real quick just to have it? Thank you. Like when Python sees this line of code, it sees the plus symbol, it looks at the thing on the left, which is an instance of the integer class. It looks for its dunder add method, which the integer class has, and then it passes in as an argument whatever's on the right side. And because we're adding integers, it's set up to, do arithmetic. So I hope that was helpful.
So it most likely will, inside that add dunder for integers, it'll probably check the type of the second argument. So if it's another integer, it'll just add it regular integer style. And then if it's not, it will probably give you an error like, oh, this is not, you can't compute this.
Okay, so to answer to my question is basically saying like that plus sign is that's how it knows that you're using the add method on top in that definition.
Yeah,
okay.
Exactly.
Okay, thank you.
Okay, I have a quick question.
Yeah.
Just to make sure I understand. So when we say we're overriding something, using the Dunder methods is pretty much allowing us to do some type of function that we wouldn't normally be able to do within the object or with the object.
In some cases, yes. So in the init method, this exists in the backend or behind the scenes anyways, it will be called. So even if we didn't predefine it, there's an init function that will create the object for us and return it. But here we're defining it because we want to add to it. So it is when you want to modify the existing one, because the existing one doesn't work for what you want it for to do.
Okay, I think I'm more so like, I think it's just the string Dunder one and then the add. So those.
So for the string one, if I didn't have this defined, it automatically prints out the type of object it is.
Okay, so that's
its
the
built-in
main,
one.
the main dog object with all of the numbers, like that pretty much helps you to be able to print
Yeah.
out. Okay.
So that's its built-in one.
Can I jump in?
Yeah.
Thank you. Yeah, when we create that dog class,
Mhm.
if we didn't define the Dunder string method, whenever we create a class in Python, Python will just go ahead and create a Dunder string method for us. So that method always exists, but the default Python one isn't very useful. As we saw when we printed out the dog object and it said like the memory location ID, whatever. So then we define our own Dunder string method, and that's what we call overriding.
Oh,
Where, yeah, exactly. It's kind of, you can think of it like what's special is honestly the name of the method. And we just know, because this is how Python works, that there will always be a Dunder string method. And so if we wanted ours to work differently, we can create our own one and it just overrides the default one. And it's the exact same thing with Dunder add, where there is some sort of default Dunder add. I don't know exactly how it works, like with creating our own class, but we can go ahead and override it. So there are all these special method names, and Python will create a bunch of these by default whenever a new class is created. And if we want our object's behavior to be different, we can override it by defining it ourselves for that class. Yeah, great question.
Okay, I understand.
Yeah, and sorry, was there something else that you want to say? I didn't mean to.
Oh, no, I get it now. I understand. It was just I think the wording that was confusing me, but I just wanted to make sure I knew exactly like what these were doing and their use.
For sure. Yeah. And thank you for asking. Yeah, the wording with all of this stuff is tricky, and we do our best. It's also like once you start working with this stuff, there's a lot of shorthand that we use. So sometimes we might like I was kind of saying, we might talk about like properties or fields or attributes, and they all mean the same thing. So yeah, if we kind of are, if you want us to like rephrase anything at any point, let us know. Yeah, and these are really core concepts, so it's good to like dig into this now. And there are a lot of moving pieces here, and it's good because we're kind of building up that mental model of like, how does the programming language actually work and what is the computer actually doing? So yeah, that's awesome.
Thank you. Michael.
So you're having variables under init. If you wanted to add a new one outside a class, can you add a new one? Let's say tricks outside of the class function.
Yes, those are class attributes, and we will see them tomorrow. So these are instance attributes, and then we will have class attributes that will, thank you, that will be out here.
And that's outside of the constructor, but it's still in the class definition.
Mhm.
So it's still within the class. Is there any way, like, I know it's not a dictionary, like a dictionary where I can add new ones later on within my code?
in that case, you might want to actually have like some sort of data structure that allows you to add stuff in. Actually, let's try this. I wanted to say self dot email equals this. And then we can just return. Actually, in this case, we won't really need to return it, but it's okay. For our sake, let's do this now. So this will execute when we're trying to print out a dog. Okay, there we go. So we have something printing out a dog.
Yes, like I don't know if we can call the create emails method in the constructor. I don't know if that works or not in Python.
So they're saying after the instructor, the constructor, sorry.
Got it.
But yeah, it seems like it created it. So if I do, after I printed it, print. Email. There we go. So it does create it and it becomes part of it, even if you don't initialize it in the beginning.
And actually, this is getting a little fancy, but in that create email method, we could even check if self.email already exists. And if it does, we don't have to do that stuff. And then we don't recreate the email address every time we print this out, which is maybe better saved for later. When we start writing a bit more complex programs, we can kind of see some of those patterns. But yeah, there's all sorts of interesting stuff you can do. And the question about like creating a variable outside the class definition, you can create variables like normal. They just won't be part of the dog class or connected to it. And like Zainab was saying, if we have, like, we can use methods to add new properties to the class. You could put a list or a dictionary inside the class and then add things to the dictionary dynamically with a method. So generally what happens is you stick some more complex data structures inside your class and then use class methods to put stuff inside those lists or dictionaries. I don't know if that's exactly what was being asked, but kind of in that general department.
Just to demonstrate what Adam was saying, so I added an if else statement here, just to check if the email has been already created, then we will just print it out or use the self.email.
That's awesome.
If not, then we will create an email. And here, I'm just gonna print.
If this question isn't germane, then just say we'll hold it, but can you give us some structure on this? So in the future, we're going to be creating software applications and we will be adding records based on the information given here. We're going to be, I expect, adding information to a database. We'll be retrieving that database to give us lists and stuff. So we're going to press a button. We're going to say, add a new user. That button's going to look to this class constructor, whatever you want to call it. We're going to add some information to the database. Where does this fit in the big picture?
So I would say that the classes that you're using are to be used within your program scope. So a lot of times you will have classes that will directly kind of map to the data that you want to hold in a database. But a lot of times you have classes that are just to help you manage your data while your code is running. so internally. So let's say I'm pulling in user data from a spreadsheet. So what I personally would do, I would pull that user data in, I would create a class to hold that data. And then I will just load it all in the class. And after that, it would be more manageable to loop through the data and use it because everything's in a class properly. So you can use dictionaries, you can use arrays, you can kind of filter, do all of that fun stuff. And then you might have like a sync to database method, which loops through all your objects that you've created and pushes it to the database. You might need to do some manipulation, do some stuff. So that's how I would see it used. Classes are used a lot in programming.
So I can imagine myself starting a new company on Monday morning and they say, welcome, Jim. Please visit this website and help to onboard yourself. What are your hobbies? What's your desk? Or we're going to tell you what your desk extension is. So they say, visit this website, fill out this information. And then I'm imagining that it's going to say, now you have to take a test to learn HIPAA or whatever it is. There's going to be a series of things you have to do. So we've added our information.
Mhm.
Now we're going to need to jump on and do one or many other things.
Okay.
Is this in a website? I think, let's just imagine this company is web enabled and they do everything via the web.
Okay.
So Jim goes in, he adds his information, gives his home address, and then he gets told, this is where your desk is at, and whatever else there might be. There's going to be a series of many steps, I think.
Okay.
So how does that, where does all this is a Python script or application we are using.
Mhm.
And again, context, how does this all fit in the big picture?
I think a good starting point is in your example, Jim, you're basically saying, I join a new company and they point me to a website and I have to enter a bunch of information into the website. With web apps, we'll talk about it more later, but we talk about the front end and the back end. The front end is basically everything running in the browser on the user's computer. So you will enter all that information in there. And then when you click the submit button, it all gets sent to, we will refer to it as the backend. Basically, the web browser sends all that stuff that you just entered in. Maybe you do it in one big go, maybe you do it in chunks. And it sends it over the internet to a server, which these days is really kind of like a virtual server in the cloud. And it's on that server where our Python code is running as part of like a backend web framework is what we would say, that receives all that information. And that's where this kind of comes in. And Zainab, I don't know if you want to take it in and run with it from there, or I can just keep talking through the flow of what would happen.
You can keep going. You can keep going.
Oh, so like we have our Python web server running on the back end. It receives the information you entered, Jim, the HIPAA training stuff. And it, because a little extra information was sent, our Python program knows, hey, this is Jim's HIPAA training. So maybe we have a Python class called user HIPAA status. And maybe it also works with the user class, but it takes all that raw data, passes it in, creates a new instance of our HIPAA class, sets all this stuff up. Maybe it has to check to validate input to make sure that there aren't typos or that a date isn't in the wrong format. Maybe it also has to talk to the database to grab information about you as a user from the database. Maybe it does a bunch of different stuff. And then when it's done, there's probably a method called save on that HIPAA class. And we'll see this later when we start looking at the Django backend web framework with Python. And then our class also, using some other Python libraries, so we don't write this all ourselves, can talk to the database and kind of has the logic of how we take this data about your status with HIPAA and your training, and it gets saved into the database. And in a database, things live in a different format and in different places for reasons of efficiency, so that we can store large amounts of data effectively. So a lot of the times the Python classes that we write are really kind of like about taking data from maybe that's come over the internet and sticking it in the database in the right spot, or getting data from the database, bringing it together and formatting it in the way that we want to present it to users, and then sending it back over the wire back to the browser. Someone asked about games. I think a lot of games are written using an object-oriented programming language. C++, I think, is used with like Unity, one of the big game engines and stuff. So that's sort of like a walkthrough of maybe like the flow of what would happen on the front end and back end of a web application for kind of the scenario that you're talking about. What we'll see is that, like, when we're doing any real work, we are using tons of libraries written by other people, but we're also learning a lot about some of the guts and some of these core concepts. It used to be that anything with object-oriented programming had nothing to do with JavaScript. These days that has changed for a bunch of reasons that we'll talk more about later. But with Python, that code is going to be running on a server somewhere. It's not going to be running in the browser. Was that helpful?
Yes, thank you.
Awesome. Thank you. I couldn't see the thumbs up.
Yep.
And Kayla, exactly. That's where Django comes in. Django does all that work for us. And when we look at Django, if you folks are curious, you can poke around at the source code for Django itself, and you'll see all sorts of really sophisticated object-oriented programming with different classes inheriting from others and things that do all sorts of work, so that, like, really we only have to write like the bits of logic that are unique to our application, and Django has classes to do a lot of the work of handling an HTTP request and parsing it and like sending an HTTP request back to the browser and things like that. Mariko, to answer your question, programming paradigm isn't quite the right word for web dev, because web apps, they touch a lot of different things. I would say there is an architecture, client server architecture, where you have one program called a server that does most of the work, and one program called the client that receives user input, and they talk to each other. And most web apps follow that, where the browser is the client and the server is, in this example, our Python program. Programming paradigms are more about languages and ways of programming. And so that's like a bigger concern than like a web application architecture. I see a bunch of other good questions. Zainab, I want to check in about a break too, and also see what's on your mind and stuff.
I just wanted to get to Ben and Michael because they've had their hands up for quite a while.
Totally.
Yeah. Ben, you can go next.
Yeah, I didn't know if I missed it or not, but was there a way to determine back at the top in your init to like, if you wanted to add like age to the list, to make sure that it was an integer, or if you wanted something that was a list, to make sure that the input was going to be a list?
Mm-hmm. Yeah, you can check that. So I think I could do here. Dot is no, what was it?
We'd probably want an if statement, depending on.
Yeah. But I was just showing the method itself.
Got it. Sorry.
No worries. Okay, so apparently Python is instance, and then hold on. Type. Okay, so you can just check the type and there's str, which is string, there's int, or I think it's integer, it might be just int. So let's say
we could, oh, sorry, you got it.
let's just do type name equals string. Let me do this. Also, this one didn't work. I have a different solution for this, but we'll talk about this later.
I think this str itself is not a string in the type checking.
Oh, it's just
Yeah, Python has
keywords.
some, yeah, it must be like a built-in object or keyword or something. It probably is a keyword or like an alias. I think you're right.
Just gonna delete this. Okay, so I mean, it worked because it was a string.
We could, you want to throw?
Sorry, I unmuted you, or I muted you.
Oh, thank you. I was gonna say we could throw a non-string in there and watch it complain.
Dog has no attribute name because we did not add it here.
And that's a great example to jump back to last week of where we might want to use a try catch block. Or to be honest, a lot of the times in the real world, you do exactly what Zainab is doing now and just use an else statement and you might not even throw an error, depending on the nature of the program.
Yeah. I mean, this would cause an error because I just printed out something, but I could just say $name equals random.
Right.
And then the name is just random because we instantiated it with 2.
Nice.
For this one here, it didn't work because it was checking for self.email. So what I would do, I would actually Google how to check if something exists. So
I can Google that. Oh, you got it.
yeah, if exists in class. Yeah,
It
you
might
could just do a
be-
try.
I was gonna say, when we're looking at it internally, I don't know. Yeah. Has attribute. It might be different because we're trying to check inside the class definition.
Yeah, so I think it's fine to just do a try catch. Try. This.
Yeah, totally. And I'm actually seeing on Stack Overflow that the recommended Python way is to go ahead and do it, but put it in a try catch. And they call it better to ask for forgiveness than permission. There's a big emphasis, an emphasis in Python on what they call like the Pythonic way, like the right Python way to do it. The idea that like Python as a language, one of its philosophies is there should be like one right way to do things, which is a little different than other languages and can be kind of cool. And I'm not a Python expert, so I often don't know the most Python-y way to do things. But from a Google search and finding a Stack Overflow post, it appears that the Python-y way to do this is exactly what we're doing now, to just go ahead and do the try catch and then handle the error. And I'll throw that link in the resources channel now too. Oh, you're muted.
Okay, there it is.
I'm gonna get a boom mic soon.
Yeah, you should. I'm gonna get one too. So yeah, on the first call, because we have 3 print statements here, so 2 for VPO and 1 for FIFO or FIFO, whatever. So the first one, it said it's going to be creating the email because it tried to check for self.email, but it doesn't exist yet. So it went into the accept clause and said it's going to be creating the email, and it printed out this. For the second call, it is just using the email, which is good. But I don't know why it says creating email again.
It's in the accept.
It is, but it shouldn't go unless there was an error.
Oh, I missed what's happening the second time.
Here. It's getting called again. I might have a different statement. I think it only happens with the second print. No, yeah. Let me see this. Creating email, using email, and then it prints out creating email as well, which it shouldn't.
Does the try block force it to go through that line of code at least once?
It shouldn't, no. For this one, right?
Yep.
Yeah, it only goes into the accept if it fails. Okay, I'll look into this a little more and I'll let you guys know. Michael.
I just wanted to make sure. So inside a class, we can have lists, dictionaries, and other classes inside a class?
Yes.
I would not create another class inside a class. That's the only thing. We'll see examples of that. Zainab, correct me if I'm wrong. I think that's the one thing you generally want to avoid.
Yes, I would say sometimes you have to, depending on the case, but you should try to avoid it.
That's a good point. And we will see it later. I also have not done tons of object-oriented programming. But yeah, the answer to your question is yes, everything, all the features of the language are available when you're writing a class definition.
Any other questions?
I have one. Do we generally want to have just one class per like file?
Yeah.
Right.
It also depends if you're using like a small class that's a type of, we'll see examples, but you can have classes in the file just for organization purposes and to make it easier to navigate your code. You should have each class be in a different one.
Yeah. The only thing I would add to that is, if a class is like 4 lines of code for the assignments right now, if it makes life easier to have all the classes in one file, I think that's okay, unless you feel like we want people to do that best practice to practice like importing.
Yeah, let's try practicing importing.
Good call.
That's why I'm giving an example right now.
Good call.
So
Yeah,
I can say,
one class per file. Sorry.
okay, so the way you import it is like just like this, like we've done before. So the first one is going to be the name of the file, and then the second one is going to be whatever you're importing. And in this case, I'm importing a class. So you can use it, I can test it out, and it works.
Which is awesome.
Woohoo.
Hey,
Other
Zainab,
question?
can we try removing the parentheses after self.email
Where?
and the dog? So where you have below in your try if, can we try removing those
Oh.
parentheses? Yeah, Jacob and I
That'll-
were talking about in the chat.
Yeah, I didn't notice that. That's probably why it gave another error. Yeah, there we go. Or it gave another like creating email one because it caused an exception and it went into the accept. Good catch, thank you.
Was the editor giving us like a red squiggly?
No,
Oh, that's concerning.
Question, actually try putting self.email on the constructor.
up here. And then if I try to do it.
Can we call create email in the constructor, or will that not work?
No, it'll work. Where is it? Oh, it's gonna be self dot. Yeah, it still doesn't recognize this as a wrong thing to do.
Interesting. I'll see if I can find a VS Code setting or Python language extension for VS Code to see, because that would be nice if it should recognize that.
Mhm.
But yeah, calling a method in the constructor like that is like a common approach. You'll see, like the constructor, you can do a lot of configuration stuff. And then the advantage here is that if we need to create an email address later on after we initialize an instance of this class, well, the method was still available and now, yeah, you're totally right. We might want to make it private because maybe we don't want to do that. Or we want it to only be used inside some other public method of our class.
So can I ask another question? So is the dog.py file a file to enter dogs into our system, are they the names of dogs and their colors and their breeds? Is that what dogs.py does?
Dog.py holds the dog class, and the dog class is just a set of attributes and methods that would allow you to save dog data and do things to dog data.
So then in the future, we will call or initialize dogs.py to add dogs, one or many dogs into the data, into a database.
So
Correct.
yes,
go
but
ahead.
we won't be initializing dog.py. This is just a file name. We're gonna actually initialize dog, the class. that's just something to note. So if I change the
Good point.
name, one sec, I can name it class dog or something like that.
So let's say we have a pet shop.
Mhm.
And we'd have the dog construct, is this called a constructor? Or would we use it to construct dogs in our database?
Yeah.
The init method, I would call constructor. If you say constructor, people will think about the init method. In Java, it's actually called constructor, I think.
Same with JavaScript.
Yeah, yeah, so constructor, that people will think about the constructor method for a class. But yeah, you're right that this dog class, we use it to create an instance of a dog object, basically to like bundle up that data and to create it. Yeah.
So let's imagine we have a pet shop then, and we sell dogs, cats, and birds only. So we bring a dog or a cat or a bird into inventory, we're gonna sell it. Then we're gonna bring a customer is gonna come in and decide to buy this dog. And the customer is either going to be in our database or we're gonna add them to our database. So I can see that we would have class dog, class bird, class cat, and class customer. Also,
You might also have class animal. If or pet or whatever you want to call it, if every single animal, regardless of type, has like specific things, like there's a this is kind of messed up, but there's like a price or vaccination records or something like that, like across the board, whatever, despite which class it actually is, whether it's a dog, cat, or bird, they all have like these things in common. You might have an encompassing class that's class animal, and this would be a type of animal. We will get into that on Inheritance Day, which is on Wednesday. So something to look forward to.
And just to add to that, and should we take a break after this?
Yeah. So the lesson is done. We're just answering
Okay.
questions and then
Yeah.
we'll, yeah.
Cool. I wasn't sure if there were other questions that we had to get to as well. But yeah, Jim, that's a really good question. I apologize for the echo. Not sure why it's happening. Oh, thanks, Anna.
That was my bad.
No, it's so hard in here with the off. To be honest, it's counterintuitively when one of us works remote, it's actually a lot easier to like teach, co-teach, and we haven't quite figured out how to do that yet though, because it is nice to be in the same office. But yeah, that's a really good big picture question. We will see all that happen later. But to answer your question, I'm going to change the scenario a little bit. We have a pet store. A new dog has come into the pet store that we have to add to inventory, essentially. So without worrying, like, let's say there's a form in a browser. The pet store owner types the information about the dog in the form, hits enter. We won't worry about the JavaScript and the HTML and the CSS. The browser sends that form information about our dog to the server where we have our web server program running, which is written in Python. Without worrying about a little bit of the plumbing that gets the data here, basically we get that form data. We call this dog class that we've created, we instantiate it like we saw in main.py. We pass in the data, and now we've created information about this dog. That is happening in the server program that's running right now on a server in a closet or a virtual server in a cloud. The next step is to save data long-term. It needs to go into a database where data persists. Our web server might crash and then we would lose all that data. So the next thing we would do is there would be probably another class specifically for interacting with the database that our dog class would make use of in order to save this information that it's bundled up in the format that we want to the database. And then if we want to retrieve that later, we would use this other class, and there's a library called, I can't remember the name of it, but we'll see it later when we work with Django, Psycho PG3. We would use some other class to get the information about the dog from the database, and then use our dog class again to create a new instance of our dog, like on the server. So this dog class kind of is like, it's the intermediary for when we get data, maybe from the user from a browser, to bundle up how we want and then pass it to something else that saves it to the server. Or when we grab data from the server, this raw data is not formatted quite how we want it. And that other class that interfaces with the database gives that data to our dog class, which bundles it up so we can work with it on our server and then maybe send it back to the browser for the user to look at.
But then can you then describe, please? So we talked about some possible classes. We have class dog, class cat, class bird, class customer. Let's imagine a class called inventory. How does the dog that we just described fit with maybe a class called inventory item?
Sure. An inventory class, without even worrying about classes for a minute, let's just talk about a list and a list of objects. Python list, we could have an instance of a dog class. We could have an instance of a cat class. We could have Fifi and Bibo and so on. And we probably should break after this. But so once we have these objects, we can put them in lists. We can put them in dictionaries. We can do whatever we want with them. And the truth is that the inventory really lives on the database. And then maybe we want an inventory class that helps us search through this list more efficiently. I think that is a really good question. I do think I want to make sure that we break the class so people can stand up and stretch. I also think that, like, by far the best way to talk to see this stuff is going to be through doing it. Because it does hit a point where it starts to become easier to simply write code and show examples. And that's what we're going to be getting into with the assignments today and over the course of the week.
I agree. Okay, any last questions? Okay. Okay, let me stop the recording.